When entering an engineering competition, I like to look at it in a very systematic and logical way, where I think very broadly at first. Here's a competition. They want to give you prize money. The point of the competition is to build a better robot than the other competitors. In this case, for the NASA Regolith Excavation Challenge, it was not about building a good moon-digging robot at all. To me, it was simply, you are competing against whoever the next guy is. So you don't have to have the best machine on the planet. It doesn't even have to be that great. It just has to be better than the next guy. And so for me, it's very higher level thinking like that, where meaning the number one priority by far is having a machine finished and testing it over anything else. And then from there, I look at what will get you disqualified. This is the real way I look at it. I look at the rules, I reread them again with just looking for things that can solely disqualify you. So I say, okay, the robot has a weight limit. Simple, I need to know the full weight of my robot. It has limited sensors. Okay, I have to make sure I don't use these illegal sensors. Then there are things that for this competition were simple, like for example, you can never go outside the confines of this sandbox. So that meant that it would severely drive how I design my robot, because I would never have a drive base where something else in the air stuck out very far. So if it ever hit into the wall at any time, it could not be illegal, even if we had, say, a control issue. And for this competition, there were, again, things like an imposed time delay, where they would say, to simulate going to the moon, they were going to put in this 2-second delay in both directions of all signals transmitted and received from the robot and to the robot. And so this means you're controlling this slow, laggy robot. And that would drive how I design the rest of the robot. And so looking at the rules, I would say, okay, you can build an autonomous robot. There's nothing that says you can't. I would look at the goal, which is just to get the most amount of poundage of material. And then I would look at what are the ways of doing that have already been done on the Earth. For thousands of years, people have been digging holes, moving sand. There are digging machines that exist. So I would look in an industrial setting, what are things that already exist? Why do they use them? How does it work? Is it applicable for the same reasons? And you get a lot of those same ideas from the industrial world. It just turns out they have a lot of different motivations usually, so the machines won't look the same. But in my case, I use those same principles that a machine driving around on, say, a sand-like surface probably should have something like tank treads so it doesn't sink into the ground. A lot of the robots showed up with wheels. Again, that was sort of silly to me because that wheels sink into sand and people get stuck. And most of the robots that did move there did get stuck.